Hello, this is Sebastian Erich from the CloudScale project. In this video I'm going to show you the first steps towards getting a complete ScaleDL instance usable by the CloudScale Analyser. I assume that you already created a partial ScaleDL instance, for instance with the ScaleDL extractor. That would mean that you have already in your project, so in my case the TPC-W project, the static structure of your system. So we can already inspect our system diagram. And see the structure of the model system based on assembled components from a repository. I will focus on one concrete aspect of this diagram. So we focus on the home page assembly in the system. So we have a bookshop at hand here, and this bookshop has a starting page. The home page component is responsible for creating this starting page. One part of this starting page is to welcome the user. When new users arrive, there's a string stating hello unknown user. And if there is an existing customer that can pass its customer ID based on a cookie, the welcome message will say welcome back user XY. And responsible for creating this welcome message is the hello component. This hello component is used by the homepage component. We will focus on basically these two components in the following. Now we are going to complete this partial ScaleDL instance by additional models that are needed to clarify the context in which this system will operate. And we need that for conducting scalability analyses, for instance. So let us close this diagram for the time being and create the missing models. We begin with the resource model. As shown above here, we can just click in the menu bar on the Search Palladio icon called Create a new resource from scratch. We select the location of our project and enter a name for our resource environment diagram. For instance, TPC-W. We press Next. We are also asked for the project location of the model for that diagram. We choose the same project here and confirm by Finish. We are provided with an empty resource environment diagram. This diagram allows us to add resource containers to it. So we can, for instance, now choose this resource container in the palette, hold the Control key, and now press 3 times on the white area. 1, 2, 3. Okay, we can now use Escape to get a normal cursor again. What I now have is 3 resource containers. Let us give them suitable names. So in this resource container I model a hardware resource, which is the database server. So far we just had the static structure of the system. Now we model also the hardware in which the system operates. One part of this hardware is the database server. Another part will be the image server. We store the images of books for our bookshop. And then the final part will be our main application server, where we store the business logic, for instance. As this application server, for instance, relies on the database server, we also have to connect the different resource containers we so far modeled. For that, we first have to add a linking resource from the palette. We have to set up a latency for this linking resource. Set the throughput rate, I will just ignore it with a 0 here. And give it a suitable name. For instance, we could name it network. Finally, we also have to connect our different resource containers to this network. For that, we choose the connection item from the palette. Again, hold the control key to connect multiple resources to the network. And from the network starting, we connect the different resource containers. And save. Now we have connected our resource containers via a simple network. As we also want to specify more properties of these resource containers, we should add also processing resource specifications. Let us do that by selecting the item from the palette and adding one processing resource specification to our application server. Now we are asked for selecting a processing resource type. Let us select a CPU we want to characterize and then confirm by OK. Next, we have to set up a processing rate for our CPU. Let us just add a 1 here for the time being. Next, we are asked to select a scheduling policy. That basically characterizes the scheduling strategy we are following. We have 3 options for that. A normal delay, which would just model a delay. So that's a very simple queue and yeah, the most basic thing, I would say. Then we have a first come first serve policy, which is basically a first in first out strategy. And we have processor sharing. That's the option I'm going to choose. Processor sharing in essence models a round robin scheduler. This is what we typically use for CPUs, as it's a good abstraction for commonly used schedulers in operating systems. So we confirm that by OK. We don't alter any other of these default values. So for instance, we don't alter the number of replicas, which would allow us to model multi-core CPUs. And we are also not interested into failures, like mean time to failure and so on. So for the time being, that's enough. We could also characterize now hard disks in a similar manner or add CPUs to the image server. But as we only focus on the homepage component and the hello component, which will just operate on the application server, it's enough to just consider the CPU on the application server at the moment. So we can move on to the next model I want to model. So as I said already, the hello component and the homepage component, they will operate on the application server. But somehow we have to specify that this is actually allocated like this. And we have a dedicated model for that. So we can close this resource diagram now and go on to the allocation model. So we choose the create a new allocation model and diagram from scratch icon in the menu bar. Left click it. Select the project where we want to store the allocation diagram file. Give it a suitable name, and I again use TPC-W for that. The same procedure for the model file called TPC-W.allocation now. We choose next, and now we are asked for selecting the resource environment where we want to deploy our system to. For that, we have to press the change button, go to browse workspace as we want to use the resource environment from our workspace, and select the resource environment we just created. Confirm by OK 2 times and press next to come to the next widget page. Here we are now asked to also select the system we actually want to allocate to the just selected resource environment. Again, we choose the Change button, browse workspace, and select the system of our TPC-W application from our project. Now we can press Finish and are provided with the initial allocation diagram. I just rearrange it as I did in the allocation in the resource environment. And we see now in the palette we have only one option to choose from. There's only the allocation context. So we are going now to choose this allocation context and add an allocation context to the application server. And here we can now select the assembled components from our system. And as I said, I'm interested in the homepage component. I'm going now to allocate to the application server by selecting it and confirming it with OK. Now we assembled the homepage component to this resource container. We should now continue this process for every component of our system. I will only exemplify that by one more component, which is the hello component. For the remaining allocations, you can have a look at the complete ScaleDL model on our webpage or in our repository. Okay, assuming we are finished with the allocation process here, we can now finish the allocation diagram. So we save and close and move on to the final diagram that is missing in the final model. So far we specified the behavior of our system, the static structure of our system. We also specified the operation environment, so the system in which the system operates, but we did not specify who actually uses our system and how these people use our system. And the purpose of the usage model is exactly that. So we now go to the last icon in the palette. It is called Create a new usage model and diagram from scratch. So we press that one, and as usual select the project where we want to store our files in, give it suitable names, so TPC-W usage diagram, and the same for the model file. We confirm by finish and are provided with an initial template for a usage scenario. So that one here is a usage scenario. I'm resizing it a bit so I can later work easier with it. And what we see here is basically the specification of one concrete scenario, how users behave. Let us first rename the default usage scenarios to something more appropriate. So we click here, press F2, and then name it Home Interaction Usage Scenario. And here we can now specify how the people will interact with our homepage component. And to specify what they do, we can use something that is very similar to an activity diagram, which is called the usage flow we can model here. So the usage flow consists of a start action where users enter the system and start the behavior we will specify, and they will end up with a stop action where they end their interaction with the system. And to add a call to the homepage component of our bookshop, we will use an entry-level system call out of the palette. So we select that and add it to this usage flow here. And now we are asked to select an operation provided role. So basically the question is which operation should be called from the system. And as we know, the system provides a home page, so the starting page of the bookshop. To access that, we first have to load the system over the Load System button. So we click it, browse workspace, as we have it in our workspace already, and select it from our TPC-W project. So we select the system model. We confirm by OK 2 times. And now see the provided roles by our system. There is the provided iHomepage interface, which we are going to access because the starting page is included here in this interface. So we confirm that by OK. And select the only operation available in this interface, which is called getHome. That's the operation that gets the home page, so which gets users the starting page of the bookshop. We confirm that by OK. And have now the system call to the home page included in our diagram. Now we are just going to connect the start, the system call, and the end action appropriately. For that we use the usage flow links from the palette. So we left click the usage flow item here. Could again hold the control key and connect the different actions appropriately and save. So now we specified that when a user starts its action, it enters the system. So it starts here, then calls the getHome operation of our system, and then finishes. We further have to specify the type of workload we will put on the system. We have 2 options for that. One is an open workload, the second option is a closed workload. Let us first of all specify a relatively simple workload. For that we use a closed workload. Closed workload means we have a fixed number of users within our system, whereas an open workload would have an arrival rate. So let's choose the closed workload and add it to our diagram, to our home interaction usage scenario. We select, or we specify that we have a population of 1 user, which is one simple case. Oh, we have to re-specify it 1. So we say we have 1 user in our system, and we could optionally also specify sync time for that user. Currently the user has 0 sync time, which means as soon as the user arrives at the stop action, he will immediately go back to the start action and re-execute the complete usage flow here. By finishing this usage model, we now have completed our ScaleDL model. Still there is a detail missing, and we will just investigate this missing detail here, and in the next episode we will start resolving this last issue. So we can close this usage diagram here, open the repository diagram again, and let us now investigate the print hello component in detail. So along with this hello component comes the behavior specification of its operations. So it provides the print hello operation, and along with that we have a service effect specification, which basically specifies the behavior of the hello component whenever the operation print hello is called. By double-clicking on the service effect specification, we can investigate this behavior. Now we see that we have a system at hand that first starts here, then a branch action comes, and then the operation is finished. Furthermore, we see that the branch action is called check for customer ID, which means here is first a branch that checks whether the customer ID equals 0, this is this branch, this condition, or whether it's not 0, which would be this branch. Semantically, that would mean whenever we have a 0 value here, we know we have a new customer. And whenever the customer specifies its customer ID greater than 0, we have an existing customer. For this demand here, we have specified, for this branch here, we have specified an internal action to happen. Here is a so-called resource demand. So we could enter any number here, for instance 1, which would mean that this action demands one CPU unit whenever it is called. What is one CPU work unit, to be precise, means specified via our resource environment diagram. So if we enter 1 here and open the resource environment diagram, and we also have a 1 here in the processing rate, the processing rate states how many CPU work units can be handled by the CPU per time unit. So currently that would mean per time unit the CPU can cope with 1 call to this method at the moment. The challenge is now to get an accurate resource demand to the CPU inside this field. Getting this value here in an appropriate way is, you can do that, for instance, on educated guess. So I could educatedly guess that this is 1, number 1, or some other value. The disadvantage is then, if I do an educated guess, that educated guesses are often not precise enough. What you have to do then is to provide a prototype of that operation and measure it. Or if you have already the complete system running, you could also measure the exact resource demand needed for this action here. And actually in the next screencast, we will learn how to come to appropriate demands for exactly this action here. So that is the task of the next screencast. In this screencast, we are already happy to have all the models that are needed by the CloudScale Analyser at hand. The only missing thing to start an analysis is to set up these resource demands correctly. Thank you for watching.